Okay, so what's that negative do on the outside? Flips it over the no time. X-axis. But then what's this negative do on the inside when I write this as negative times x minus 3? Well, if the negative on the outside is x-axis flip, what's the negative on the inside? Y-axis flip. Now this is the parent function. And this is driving me crazy that I almost cover this every single day. The y equals 1 over x function has a vertical asymptote at the x-axis and a horizontal asymptote at the y. The reason for that is the numerator's degree is 0. The denominator's degree is 1. By default, it's y equals 0 as a horizontal asymptote. So those are your rules that I've almost stated every single day. All right, at some point, hopefully it just sinks in. And then the graph is here and here. That's the parent. Because I wanted to really show you what happens here mathematically. If I flip this, let's get this so you see what I'm doing in class a little bit at least. If I flip this over the x-axis, then we're here. But then I flip it over the y-axis, where am I at? Right back where I started. Or do you know what a negative negative is? What's a negative negative? It really is a positive. These can cancel each other now that I have that negative isolated outside. So really I could graph that, 2 over x minus 3, then minus 1. What's the minus 3 do? Which way does it shift? Right or left? We should know it's either right or left. Which one is it? Right. What's the minus 1 do? We should know that it's up or down. Which one is it? Down. So right 3 moves the vertical asymptote. Or if you stayed with the beginning and didn't do those reflections, I cannot plug in 3. 3 negative plus 3 is 0 on the bottom. That is why that is a vertical asymptote still. So even if you look at the original, we still should have known that it's x equals 3. And then y equals negative 1. And I did a bad thing with the other hour. It does say state the domain and range. Well, let's do a quick graph of this. And I could input output. I'm going to bore you with it because I don't know why we're struggling with input outputs. I really don't. 4 negative. What's negative 4 plus 3, everybody? 3, 2, 1, go. Negative 1. Not enough people. We're too dead out there. Blah. What's 2 over negative 1? 3, 2, 1. Negative 2. But it's negative. So what's a negative negative 2? Positive 2 minus 1 is what? 1. That's how you evaluate. Wait, what did I plug in? I forgot which one was that. That was 4. Thank the maker. My bad, dogs. That tells me everything. That tells me that the graph is above here. Hence, what I just said. X-axis reflection, but then y-axis reflection. We start right back where we were supposed to be. This curve up here. Controlled by the asymptotes. And then one other quick annoying input output. Negative 2 plus 3. What is that? 3, 2, 1, go. What's negative 2 plus 3? 3, 2, 1, go. 1. I heard a 5, and there's a negative and a positive. So we have a subtraction there. So it's 1. What's 2 over 1? 3, 2, 1, go. 2. We lost fifth hour. Negative 2 minus 1. There's a negative there. What's negative 2 minus 1? Negative 3. We should know our negatives. We don't know those enough. I get all these crazy answers from the seniors. A negative minus another number is a bigger negative. Know the basics. All right, so anyway, that proves that part right there. All right, so they did ask you to graph, and therefore they did ask you for the domain of the original. Okay, so the domain and the range is everything but that vertical asymptote. I don't know what we can do to get these vertical asymptotes locked in. Just keep reminding you until it sinks in, I guess. And then the range for the original is everything but that horizontal asymptote. And then I could already tell you what the domain and the range of the inverse will be. These two flipped. The inverse will have a domain of this, everything but negative 1, and a range of this, everything but 3, and we'll prove it. Okay, so now in green, when I say inverse, you say switch what? What do we switch? Switch x and y. All right, so h of x is y, so now it's x. And then, you know where that negative actually can go? It can go with the 2. It might be smarter to do that. Doesn't go both top and bottom. A negative over a negative is a positive. Let's stick that negative on the 2 instead of it floating on the outside. And then this is over negative. This turns into y. And then a big fat -1. What should I move first in solving for y? The -1, which means we +1 to both sides. Now, I tell you, at this point, we at least have, some points here. This might be, if I ask you to graph all of them, it's a lot of multi-step questions. This would be separate graphing, but it's kind of putting it all together. This is review right here, by the way. This is reviewing what we were supposed to know for our quiz last week. So doing that red, we're actually reviewing for the test right now. We need to be tricked and understand that we know that. X plus 1, and then equals, and then this is the whole fraction idea. Fractions just destroy the students. This is all over the years. No, nothing COVID at all. The last 10 years of teaching fractions are a disaster. All right, we can look at this two ways. Make this over 1 and cross multiply, or multiply both sides by negative y plus 3. It's the denominator that I have to clear out. So if I don't want to do that. I'm going to cross multiply and we'll be in the same spot. If I cross multiply, this times this is x plus 1. Yes, you need parentheses. Negative y plus 3. And then 1 times negative 2. If you would have multiplied negative y plus 3 both sides, that would have canceled. Directly, you would have got negative 2. And then negative y plus 3 times x plus 1, you're right there. Same thing. Same thing. Now, this is where you're going to be mad at me. How many y's do you see? How many y's do you see? 1. So I made her FOIL. And I'm like, and then we look at the answer, and our answer was way different, but it was the same graph. But what could I do with this since there's no y in it? What can I do with that chunk right there? Divide it. You can divide that whole chunk, and then we already know what the vertical asymptote is. I'm sorry, Gabby. Remember that answer that we saw? This is going to match that one now. And I'm telling you, they're exactly identical. It's just weird how it depends on how you write your answer at the end. And then it becomes easy. What do you do next to get y by itself? What do you do next? Subtract 3. Hey, subtract 3 like this. So you see that it's 3 down right now, but it's not. Because you know what else you have? You don't have y, you have what? Now, what do you do to get rid of that negative? I know what you're going to say. You're probably going to say divide. Divide by what? Negative 1, but actually you could also multiply by. Say it. And I think you should multiply by negative 1 both sides. Whatever you do to one side, say it. But this side, you must distribute that negative 1 and multiply. And then that changes what happens. Now, what we should know, this is multiplication, not subtraction. We should know that negative 1 times this fraction. If you would have left the negative out in front, then you'd see it better. But negative 1 does just get multiplied up in the numerator and turns that to positive. I know what I did wrong. I think I had still a negative up there. And then this -3 becomes a +3. I think last hour I left a -2 over x plus 1, and it gave me an improper graph. So that is it. So what is the vertical asymptote? X equals what? -1. What's the horizontal asymptote? Y equals what? 3. Sorry for the delay there. So you know what the domain is? Everything but -1. Didn't we just say that? Didn't we just say that was going to happen? Didn't we? Answer me. Thank you. It's like at home when I talk to my kids. They'll just give me looks of death. Hey, thanks. How was school today? All right. I'll be upstairs if you need me. Actually, Lexi finally was talkative yesterday. That was nice. And then y cannot equal 3. And then we're going to go ahead and graph that real quick. So notice the horizontal asymptote for the red was y equals -1. The vertical asymptote is x equals -1 for the inverse. True that. X equals 3, y equals 3. That's part of that whole thing about what's going on there. And then, yeah, my graph was not symmetric because I think I left that -2 over. And I did input output just to see what the graph looked like here. So I put in 0 because it's not a big deal. Yep, that's where I went wrong. I know it. I know I had a negative there. What's 0 plus 1, everybody? 3, 2, 1. If you don't answer it, I'm throwing a desk. 1. What's 2 over 1? 2. What's 2 plus 3? 5. Thank you. Did you answer? Good. Okay, so I get 5 as an output. 0, 5. Wasn't that fun? All right, and then this graph is up here then. Okay, I see that symmetry when I draw the y equals x line. I know I jacked up something here, but I just wanted to move on with the other class. When I draw that, look at, okay, good. All right, and then on the bottom part, it's going to be here, some way, shape, or form. And then if I draw the y equals x line, it does really show that symmetry. Look at the red and the green, perfectly reflected over that black line I just drew. So unfortunately, the other hour I made a mistake. So sorry, fourth hour, but we had to move on. I didn't want to keep harping on this. All right, any other number from this section? First person that has a hand up from this thing before we turn it in. 3, 2, because I had the answers on pages 3 and 4, and you should have checked them. 1 after valid. You didn't even have that out. I just did number 18 on that thing. 0. I'll just turn it in then. Nobody. Forever hold your peace. You got something? I really feel like there should be something, huh? 15 or 16? 1, 6? No, I just showed you. Okay, that looks like a bunch of chicken scratch. And then we'll move on to the notes because we have to. This is just inverse, right? Right? Just finding inverse? Okay, I just wanted to make sure the direction's not just. I mean, this is one of those tough ones. So this becomes x equals 3 over y minus 1. To be honest, but it's good to see again, this is just like the last one. It really is going to be very similar work. What do you think the first thing is going to be that we do? Yeah, so add 1, right? And I would hope you could write it like this. Just go ahead and x plus 1 equals 3 over y minus 1. Then the next thing is probably cross multiply or multiply both sides by y minus 1. The next thing you should see is x plus 1 times y minus 1 equals a lonely 3. And I think I might have done something screwy last year. Because now what do? I just showed you. What do you think, everybody? There's only one y. So what can I do with this x plus 1? Divide it. And then that shows the new vertical asymptote. I think it did ask for domain and range on the original and the new on this. And I don't know why I need parentheses anymore. And then what's the last thing you want to do? How do I get y by itself? Just add the 1. So what is this called? G of x? So the inverse of g of x, whoops, I forgot that -1, equals 3 over x plus 1 and a big fat plus 1. Right? Because I added 1 to both sides, and that's the way it should look. So it transformed. Sure, 3 is a stretch. Doesn't really affect the graph much, but the new vertical asymptote at x equals -1. Horizontal asymptote up 1. Y equals 1 when it's in transformed. So that means the domain is everything but -1. So annoying to have to write this in interval notation. That's because of the x equals -1 vertical asymptote. And the range is everything but 1 because of the y equals 1 horizontal asymptote. They did ask you for domain and range in that section. Now, I was supposed to do it in the beginning as well. All right, and then we could turn that in. And then you can see that the vertical asymptote is x equals 1. So that is not equal to 1 for domain. -1, y equals, for the horizontal asymptote is 16. All right, go ahead and turn that in, and then we do have a few things to look at here. Then I'm going to go to those notes. Inverses, how many did I do here? Oh, those were notes from yesterday. Boom, boom. Oh, baby, here we go. All right, so I forgot a couple things with the other class as far as what they asked you here. I'll show you what really happens when we have graphs finding their inverses and stuff. So I have a picture here. I'll help you on this. By the way, when I say inverse, you say switch. Say it. Switch x and y. So, but let's read these directions first. I went a little fast with 4th hour. Determine whether the function is 1 to 1. If it is 1 to 1, sketch the graph of the inverse. And I'll tell you why that's the case here. First of all, is this a function? Vertical line test. Pass or fail? Pass. Does it pass the horizontal line test? Pass or fail? Pass. So it's 1 to 1. I'll show you why that's important. Only 1 to 1 functions, when you find the inverse, it'll be a function. And that's what we care about most. But here's how you take a picture and find the inverse. It's actually very easy. Input, say it. So this is a set of coordinates. If I don't give you the coordinates, then you make them up. For instance, doesn't that look like that's possibly 0, -1, right? And if I knew that was -1, this looks like a horizontal asymptote at y equals -2, right? Yes, Mr. Sanders. And then it looks like possibly 1, 1. So I'm going to go ahead and mark it, dude. And then 2, 5, approximately. It looks like it's right around there. See, on the test, I'll have a grid here, and you'll know what these points are. And you could pick enough points to get the shape of the graph. And it shouldn't be that big of a deal. And then to demonstrate this asymptotic behavior, this is -5 here. Make up something. Okay, so if it looks like there's a horizontal line through -2, then this is like -5, comma, like -1.9. And that's an estimate. That's the idea of an asymptote. This is approaching but not crossing. Okay, so that would be a reasonable coordinate. Everyone okay with that? When I say inverse, you say switch x and y. Here's your new graph. Your new graph should therefore have these coordinates. 5, 2. Oh, switch 1 and 1. 1, 1. Switch negative or 0, -1. And then this is going to be an asymptotic point here. This is where we have some asymptotic behavior. But then I also want to tell you something right now. When I find the inverse of something with a horizontal asymptote, it's got to have a vertical asymptote. That is actually true. As a matter of fact, in those exponential, wrong, in those rational functions, that is why if the original had y equals 2, then the inverse has x equals 2 as an asymptote. It's the reflected asymptote over the y equals x line. Okay, but we'll see this as I graph these points. 5, 2. Oh, okay. So that's, remember at 5, 2, that's when that graph is starting to take off. This is going to take off but be like flatter over here, but still rise forever. 1, 1, shared point. -1, 0. Oh, and then -1.9, -5. This is the point. The x's are going to be approaching -2 now, not the y's. That's why there's that boundary there. Oh, this always makes me sad because we don't have these memorized. What kind of function is this over here from our book? What's the name of it? What's the only function that only has a horizontal asymptote? Starts with an E. Exponential. This is for sure exponential. And then in chapter 3, we're going to be graphing these, which was also in your book. It was the only one that only had a vertical asymptote, and it's a log. This is a logarithmic graph. Yes, logarithms are inverses of exponents. They are, and that's the whole meaning. That's the whole reason they exist. The mathematical concept. Okay. See, now this should happen immediately. What family of function is this? Only one function behaves like this. 3, 2, 1, go. Square root. This guy is going to have a good test. But I want to throw this test again because everyone should know that's the square root function. It's the only one that has a starting point and then curves. So everyone should know that this is emulating the square root function. But for the purpose of this, first of all, is it a function? Come on, yes or no? Is it past the one? Is it 1 to 1? Yes. So its inverse will be a function. This is -3 comma -2. This appears to be, what did I think? This looks like -2 comma -1, and you could do this as long as you're reasonable with the coordinates that you pick. Then when you switch the x and y, you'll have a very good drawing. This looks like 1 comma 0, and then let's guess that this is 2, 3, 4, 5 comma 1. So you just get some good points to get good shape, and then you switch them. So now for my new graph, very simple idea. 1, 5, 0, 1, -1, -2, -2, -3. All right, so 1, 5, 1, 5. Oh, so I'm way up here now. 0, 1, -1, -2, and then -2, -3. And what does this picture look like? Half of a what? Half of a parabola, because it's a restricted domain x squared function, and that is the inverse of a square root. Square root and x squareds are inverses of each other. So that's why we get that behavior, that looking picture there. Okay? All right, and then the last one, is this a function? Yes or no? Yes. Why? Does it pass the vertical line test? Is it 1 to 1? Now, the reason we don't care about this inverse is it's going to be a bunch of squigglies going up and down like this. I think it does end up being like somewhere over here. I'm going to be real lazy about that. Is that a function? Yes or no? No. So we don't even find the inverse of that. We just move on. Okay, now here's the tough part. Here's our tough mathematics today. This is number 3 on your worksheet. And also 27 through 31. 31, put a star by it. I'm going to show you how to do 31 on our second example. And some of you may faint, all right, because it's going to be the hardest math you're going to see all year long. But I still want to do it. I just talked to the other CAT teacher, and she said she didn't do the example. And I go, you know what? I still want to do it for those that are going to take calculus next year. This was a normal question, number 31. This was something that I expected CAT students to do like 5 years ago. But then some things happened with our curriculum and blah, blah, blah. That's made it us be able to do less in this class. Just being honest, it is true. But I think many of you will be able to handle it. And I think something like number 31 will be in the extra credit to separate those that can handle that and who are ready for, not necessarily ready, but if you give it a good college try, you'll be good. But here's what's true. This ties the two sections together, 1-4 and 1-5. And this first one you should not really feel that bad about, but we'll see. All right. If two functions are inverses, then this will hold true. If I do the composition of functions f of g of x, I should get x, not a number, not 1, not 5, 1x. And then I also should get from g of f of x, switching these, x as well. And if these two things happen, then the two functions are inverses. You are going to have to show that work in at least one question, probably more so like this 28. Not going to get real complicated with it. So expect to see that. So specific directions, look at exercises 29 through 32. I give you 27, 29, and 31. You should definitely be able to handle 27 and 29. And then you're in good shape, in really good shape, if you handle 31. If you can follow along my next example. But this one, this is what they're saying. These should be inverses, but you must prove it. Ah! Okay? You don't know what just happened in class. I just got sabotaged. I got kicked right in the groin by technology yet again. And it happens every single day. Okay, so I guarantee something else is going to happen when I do this. I bet you it's going to blacken out my screen. Come on. Okay, connecting. Was it this class that I kicked my pen? Or no, was that fourth hour? Okay, I took it and I kicked it yesterday because my pen was acting ridiculous. Okay, we're okay. I'm sorry, internet, for throwing a fit. Okay, here we go. F of g of x. This is the test. Did you see the directions? Confirm they are inverses. That means they know they are. So I should get what I'm going to get. And it's all about the work in the middle. So if you guys know that it's supposed to be x at the end, great. But I need to see valid work that proves it throughout. So the first thing you have to do is conduct an f of g of x test. Okay, and then what do you do next? Hopefully, and I think this connected, and I hope it worked pretty well, that what you do first is replace the function for the name. So the name is g of x. It's defined as 4x minus 3. Where did g go? You're killing me. G of x is just the name. Replace its functional value there. So actually I should highlight all of this and say, okay, that's what I'm replacing where I see that name. Next thing, I like this highlighting. I go to the f function, and wherever there's an x, I replace it with this thing, right? And that's what we need to figure out on those, and I think we're doing all right on that from some of the work that I've seen. So the very next thing I should see is 4x minus 3 plus 3 over 4. And always what I get as a question here is, wait a minute, where did the f go? And you're killing me. F is just, hey, go to the f function and then do this operation, which is plug this in for that. Okay, I did that. That's where the f went. The f is just giving me direction on where to plug it in. Just the name. By the way, what's 4x minus 3 plus 3? What happens with minus 3 plus 3? They cancel. And by the way, what's 4x over 4? What's 4 over 4? 1. So guess what? You put check baby, 1, 2, 3, and you move on. That was not very hard. Okay? Then you have to go to proving g of f of x equals x and go through that process. Now my highlighting is going to be all wrong. I'll try to get rid of everything I can. I can't get rid of that one. Sorry about that. But I can do this. What's f of x? That. So the very next thing I'm going to do is replace the name f of x with its functional value. And then I guess I can keep using green. What does this mean? Go here, and wherever there's an x, replace it with whatever's in those parentheses, which is this fraction. I should have asked you this, by the way. What are both of these graphs of? What's the second thing a graph of? Line. And I did that first because the first one you guys try to make up stuff. What's this a graph of? It's a line. Don't think it's like, oh, it's got asymptotes because there's a fraction. There's no denominator variable. This is actually 1/4 x plus 3/4. Slope is 1/4. 0, 3/4 is the y-intercept. By the way, what happens to the 4s, everybody? They cancel. We're so poor with those fractions to not see that right away. That is a beautiful thing with a set of parentheses there. Those 4s cancel to be 1 over 1. Hey, and by the way, what happens with x plus 3 minus 3? Turns into x, and then you know what you say? Yes, inverses they are. Well, let's say it like Yoda. Yes, inverses they are. I guarantee that's how hard 27 and 29 are. Not. Oh, you ready? Here's the question that separates the students. This is the one. This is the one. This is the ones, and it always makes me sad how many students turn in the test with 15 minutes late and don't even attempt the extra credit these days. They don't try to go above and beyond. So, just giving you a hint here. All right, so we'll tackle this, and then this will be the end. Oh, brother, you ready? So I have to do f of g of x and prove this ends up being x at the end. And it's all about the work in the middle. Any invalid work that isn't cool, doesn't make any sense, the question's over. Okay, so sorry about my highlighting that transferred over from an old set of notes, but just number 32 in our book. And like I said, you're doing 31. The very first thing that happens is wherever there's a g of x, I put that in its place. Oh, okay. So this is f of 2x plus 3 over x minus 1. And again, remember what I said, that it doesn't matter what's in here. It really doesn't matter what's in here. F of this means I go to the f function. Wherever I see an x place marker, I get rid of that and I put that in its place. Doesn't matter how ugly it is. Okay, so here's what you see next. X, no. Wherever there's that x, I got to put this ugly thing. Plus 3. Make it real big. And now that's our numerator. And I will highlight this. The highlighting is actually working the way I have this highlighted. Notice the yellow x is now replaced with the 2x plus 3 over x minus 1. Really not a hard thing to do the first insertion anyway. And then wherever there is an x, I put a 2x plus 3 over x minus 1 yet again. Minus 2. All right, so I put that big fat minus 2 there. All right, and then here's the first ridiculousness that I'm going to see people do. Is this legal? Oh, this is exactly the same as that, so I can cancel those. Yes or no? And you know what that is? That's a 6 over 5 equals 2 error. Because isn't 6 5 plus 1, everyone? Yes or no? Isn't that true? First of all, say yes or no. Fifth hour, who doesn't talk to me? All right, it's 5 plus 1. And then don't these 5s cancel? No! 6 over 5 does not equal 2, so that is obviously bad math. You can never, ever, ever cancel part of a sum with, another part of a sum or anything that is individual. That is mathematically uncool. Okay, so we got to stop doing that, and some people did that horrendously, and I gave them no credit on questions where that was a thing that happened. That was a chapter PR test. I'm getting ready for what you're going to do. And this is it's going to be the separator between those that can handle this and not. I'm going to multiply by something. And then someone on last hour pounced on it like a cat in cat class. Nice. I'm going to multiply both top and bottom by a set of parentheses. What do you think those set of parentheses are going to be? Let's see if anyone wanted to mention something. Adam, you had a great day today. What do you think it is? Not a reciprocal. There's only going to be one set of parentheses. Only one binomial instead. Go ahead. Boom shakalaka. It is the least common denominator of the little fractions. By the way, I don't know why I put an extra parenthesis there. I hate having to go to... Wait, does this eraser work? Wait a minute. Maybe it is this. Hold on. Nice! I forgot about that. I got a button on my calculator that can do the eraser. Do you know what this is equal to? It's equal to a number that starts with an O. Not many numbers start with the letter O. I feel like Elmo, the letter O. What number starts with an O? 1. 1. That's equal to 1. Oh, another kick in the groin for Mr. Samuelis. All right, so I've multiplied this by 1. So I haven't changed its value. Now I know you're freaking out, but here's what happens. This is why I made this choice. When I distribute this, what happens when I throw an x minus 1 to that fraction? It's the whole reason I picked it. Starts with a C, C-A, C-A-N, C-A-N-C. Cancels. And I'm left with a 2x plus 3. And that is now not a fraction, a little fraction. The x minus 1's canceled. This is why I chose this. Oh, but here's the other thing. This has to get multiplied by it as well. So it's 3 times x minus 1. This is not like calculus algebra, but your calculus teacher is going to be very upset with you if you can't do this algebra if you do go to calculus. That is true. It's like they get very frustrated. And that's what you're going to have to work on. It's not going to be calculus that's going to get you, folks. It's going to be algebra. It really is. So working on those skills. Same thing. Cancel. Oh, and then don't forget, minus 2 times x minus 1. Here we go again. Should I cancel these two? Yes or no? I'm going to get it. People are still going to do it. Should I cancel these two? Yes or no? No. Those are all still parts of sums or subtractions. You cannot take part of a sum and cancel it with something else. So it looks like you want to do that, especially the x minus 1s because they're in parentheses. But no, they're part of a big mess of plus and minus and still not cleaned up. So you got to clean up. Clean up, clean up. Everybody do their share. Do you even know who that is anymore? This is fifth hour. No one talks. I can't tell. I can ask them anything. Hey, what's 2 plus 2? And they look at me like they want to kill me. Does anyone know who clean up, everybody do their share is? Yes, who is it? I don't know who it is. It's a dinosaur, right? Barney. There you go. Nice. You guys do remember. I'm just checking my age and if my references as I end my teaching career, which ones still work. Barney the dinosaur. Okay, anyway. Hey, what happens to the 3s? I got it. Hey, what happens to the 2x's? Cancel. So guess what I get? 5x over 5. Hey, by the way, what's 5x over 5? Oh, guess what? You're halfway there. Because now what do you have to do? Prove g of x, g of f of x equals the same. So I'm going to zoom in on that. Well, let's get rid of our 6 over 5 equals 2 error work. Oh, still had people do it. I know it's a lot of stuff to remember, but, I'm trying to give you every piece of information you need to be ready for calculus. That's the really point of this class. Or at least if you go to college, retake this class. Remember I told you I did that. I took a pre-calculus type class in high school as a senior and then redid it my first semester. Got an A triple plus and then moved on because I was ready. It was prepared. And that's what we're trying to do. All right, so it's g of f of x. Let's get it set up first. First thing is it's g of f of x is x plus 3 over x minus 2. So that's what f of x is equal to. The next thing is I go to the g function, and then wherever there's an x, I put that x plus 3 over x minus 2 in. So this is what it looks like, and then I'm going to zoom in on this. 2 times, I'm going to write it like this. 2 times x, which is x plus 3 over x minus 2. So I'm looking at that plus 3. So I wonder if I can erase this. So that's what I'm replacing. I'll put that in yellow if you can see that. So the x goes away, and I put that in its place, 2x plus 3. Where'd g go? I went to the g function. I don't write g again. All right, over, and then x minus 1, but x is x plus 3 over x minus 2. Okay, now I'm going to zoom in on that. Everyone should be able to get this right because you looked at the first example and saw what happened. What am I going to multiply by? X minus what? 2. And I'm going to leave that 2 on the outside. Just watch what happens with it. What happens with the x minus 2's? Cancel. And then now we can put that 2 times x plus 3 like that. But don't forget that the 3 gets multiplied by that x minus 2. No more little fractions. That's what that took care of. And then what happens with the x minus 2's here? Starts with a C. Should I cancel those x plus 3's? No. Don't forget x minus 2 gets hit by this 1. What you do in the numerator is distribute. And then you end up with a very similar math. Minus x plus 2. Okay, so make sure you distribute that negative all the way through. I made a mistake. Oh, I'm a maroon. I didn't distribute the 3. I knew something was wrong. What happens with the 6's? I didn't cheat there. I forgot to distribute the 3 times 2. All right, so I knew I made a mistake there. Minus 6's, and then the x's cancel again, and then you got the same thing. 5x over 5 randomly ends up being x. They are inverses. Hoi! That's a big one. All right, so I want to see who's capable of doing that on the extra credit. I bet you a lot of people will be done with 5 minutes left and you turn it in. I'd like to see it, though. I'd like to see people up to the challenge that proves that those are inverses. Whoo! Okay, told you it should not be a very big